all right. Thank you very much. I love that voice. All right. Okay, so let's dive into this. If you are just joining the call, you are welcome. We are just kick starting this. So, like I said earlier, this session is meant to be 2 days free class, and we're going to be diving into SQL. This class is going to be for 2 hours, from 7 to 9 p.m. So we have like 2 hours to like dive into some of the uh, fundamentals and concepts of SQL, most especially when it comes to data analysis and data science. So if you're on this call, you happen to be someone who's already into a career in data, either as a data analyst or a data scientist or a data engineer, and I think this class is also for you as well. So you might want to like learn one or two things or upskill yourself in terms of understanding of SQL. And about if you are also joining this call for the first time, or this is your first time using SQL or even hearing about SQL, so don't be too worried. This class is designed for you, so it's designed for beginners. By the grace of God, we are going to dive into understanding all the core concepts that we need to understand even before talking about programming. We are going to break down all the concepts. So in case you are an intermediate or an expert and you look forward to getting uh, maybe complex queries or analysis in this class, so this is not a master class, it's majorly a beginners class, uh, focusing on those that are just transiting into tech or those that just want to learn about SQL. Is that understood, guys? All right. So we start wasting much time. Uh, let's dive into this already. So I will start by introducing myself, and after then, I think we'll give room for at least maybe a female and or a lady rather, and also uh, one guy or one male, as the case may be, to also introduce themselves, so we can have a better platform to start. So for those that are just knowing me for the first time, my name is Oyeko Mileko, uh, and I happen to be a data scientist at Coda Tech Africa as a mentor, and I've happened to like train a lot of students, especially when it comes to the field of data analysis and data science. Currently, I'm also looking forward to also, as you know, in tech, it's all about continuous upscaling yourself. I'm also looking forward to also transiting to things like learning more about data engineering and some other advanced concepts. And most especially, or most importantly rather, I'm also not a successful content creator. So some of you be wondering what that means. But my own content creator is not yet successful. So I hope we'll be successful one day. All right. So that's a little uh, introduction about myself. Uh, okay. So can I get one female and one male, a volunteer who would love to introduce themselves and why you are on this meeting? Can I get a volunteer? Please and please. Let's make this meeting interactive, please. All right, all right. Any volunteer? Or should I call names? Should I call names? All right. Can Duro Tosin. Is Duro Tosin on the call?
Yes, sir.
All right. Okay. Can we get to know you, please? Very
My name
short.
is Oluwatosin.
All right.
Data analyst student in progress.
Okay.
Data science currently.
All right.
That's the
Okay.
career path.
All right. Okay. Thank you very
Looking
much.
forward to
Okay.
insight what SQL like fundamental and also some advanced queries in SQL as well.
Okay. All right. That's
Thank you, sir.
interesting. All right. So it's nice meeting you. Uh, Ayomiposi Ajibari. Please, are you there? Can we know you?
Yes,
All
I
right.
am.
All right.
Good evening, everyone.
Good evening, sir. All right. Can we get to meet you, please? A short introduction about you. Sorry for putting you on the spot.
Okay, my name is Ayomikosi Ajibari.
Okay.
Um, should I say I'm a data enthusiast now?
Okay.
I just like data, anything data, so data science, data analysis. So
Okay.
I'm into both actually, data science
All right. Okay, that's
and
interesting
data
to hear.
analysis. And I came across this link on LinkedIn.
Okay.
That's why I actually joined today. So I'm happy to be here. Thank you.
All right. Thank you very much. That's interesting to hear. So I welcome everyone. So it seems we have a combination of people who are data analysts, data scientists. Possibly we might also have data engineer too on this call, and we also have people that are just transiting into this field. All right. So let's dive into this without wasting much time. I've gone into some introduction about what this boot camp or what this training is all about. It's basically designed for students or career people who are looking forward to transit into the data space, irrespective of any career you're trying to go into, either as a data analyst or a data scientist. SQL is one very important programming language, and I usually tell people a lot, though I didn't know these two also in the early phase of my career, so I get to know this later on when by the time we start working. So, and it's important that we also inform people. So I think from my own understanding and from research, if there's any programming language you like we want to dive into as a data practitioner, I will always recommend SQL as the first programming language you should learn about, and you will see some of the reason why we have to do that. Okay, so your learning outcome, what you are going to be taking out from this class: one, we are going to be diving into the fundamentals of databases. You are going to be understanding what exactly is database, what are the core concepts that you need to understand about database. So majorly today we are going to be doing a lot of should I say theory, and if time permits we might also go into some code writing as well. But today is focusing on understanding all the basic building blocks of databases, and what it means to get your data into a database, what it means to do modeling, what SQL itself as a programming language, what it also mean, and why it is also important to business organization. We are going to deal with all of that. So at the end of this course, you are going to be getting at least the fundamental knowledge of a database, and how to extract data, how to load data into a database, and how to even make reports from a database. Exactly. So without wasting much time, let's dive into this. So the field of data analytics itself, this is not the first time you guys are hearing about a field like this or a career like this. So you might have seen it online. If you have not into that field already, you might have seen it online. Different schools uh, talking about enrolling for a data analysis course, and this is one of the importance of training like this. So what Coda Tech Africa does is that we organize free session like this to give opportunity for those who probably did not have the privilege of enrolling for a course. You get, so there should not be barrier when it comes to learning a skill. So that is that's the major reason for program like this. So when we talk about data analysis, what is actually data analysis? What is data analysis all about? So in a very clear cut, when we talk about data analysis, this simply means the whole activity or the process of examining, cleaning, transforming, and interpreting your data into what? Into a more discover useful information that draws conclusion and support decision making. So these are just English. So in a lighter note, for those that just transit into this, the whole idea about data analysis is to be able to to derive insights from your raw data. So when we talk about raw data, we all know what raw data means. Data, like raw facts, basically. So, and if you look around you, there is data everywhere. What we are doing right now, we are communicating data. Some people might be surprised that what does that mean? We are communicating data. Every activities we are doing right now is all about data. Like for example, the numbers of participants on this call is a data. So but that is just a raw data. You cannot make meaning out of that particular data. For example, if I say the numbers of people on this call are 15, everybody on this call, either you are tech related or you are not even into tech yet, you understand that this is a figure. The numbers of students or participants on this call is 14 or 15. It's just a number. It doesn't make any sense. But with the skills of data analysis, with some techniques of data analysis, you are able to make meaning out of those numbers. You are able to discover insights that can help in what in decision making. So that is the major role of a data analyst. So forgive me, I might be using data analyst and data scientist interchangeably in this class. So, and the reason for that is because we play most of our role are like very similar. So they are very similar. So when I say data analyst, I'm also focused on data scientist. And when I say data scientist, I'm also focused on data analyst, because this particular tool we are discussing right now is a tool that is common to both field, right? Okay, so that is basically what data analysis is. So as a data analyst, what you do in a company is for you to make meaning out of numbers. You make meaning out of numbers. You understand? Okay, and this is what businesses use in making decisions. Is that understood? So when it comes to the tools, there are many tools available in the market space now. We are talking about tools like SQL, which is what we are here to discuss today. We are talking about tools like Python, Power BI, Excel, which is something everybody's know very well. Excel, that's the Microsoft Excel. We are talking about programming like R, Julia, the Google Local Studio, Tableau, Apache Spark. So many of them. There are so many tools in the market, and this is where a lot of students or a lot of people, when they ask questions like, which tool should I go for, which tool should I go for, which tool should I go for. So I always get this question a lot, but trust me, I don't know every 2 year. I don't know every 2 year. If I count the numbers of two I've worked with over time, yeah, there are probably like 4 or 5 of them. So you don't necessarily have to know all the tools. And just like one of my mentors will say, the most important thing when you are learning anything is the what is the concept. Try and understand the fundamental understanding. Why is that thing even important? Because as per the tools are very, like, they are numerous. Before we wake up tomorrow, now you might hear another two coming out. You get? So tools are, they are always there and they will always come out. So don't focus much more on the two, but the core concept. Why is this knowledge important? What is the value? You understand? This is going to apply to you or to the business. So as for the two, you can use any two. You understand? So that is why we are going to take a lot of time now to dive into the concept and fundamentals of SQL, of database itself, before we now even talk about SQL. Is that understood? All right, and this is also to also encourage you. So this is a current analysis done by 365, uh, looking at the research of how popular SQL is when it comes to diving into data career. So if you look at this current research, SQL seems to be topping the chart, then followed by Python, then followed by How. So this shows us how important the SQL programming language is. I know for those of us that were already into data analysis or data science, you probably might have this information already. But for those of you that this is your first time hearing about SQL, or this is your first time diving into this field, trust me, if I have known this earlier in my journey, I probably might have, you understand, probably gone too far more than this. SQL. SQL is very, very, very important. Trust me. If there's any language you like want to make your Bible, yes, I think that is right. Like if there's anything called data Bible, so the language that Bible is going to be written, for the Christians in the house, please forgive me. So you can also say data Quran too. So because that seems to be, let's say, the holy book of data. Very nice. So if there's anything to be the holy book of data, it's going to be written in what language? Anyone? What language will it be written?
SQL.
SQL. Thank you very much. So if in case that is from you. You understand? Don't think it's not available online, but that is from me. So don't think it's an official statement. All right. So, but I just feel that if there's going to be anything like the only book of data, the only language that book is going to be written is what is SQL. Just to emphasize on how important the SQL is. You understand? It's a programming language, and that is where the headache now comes in, because a lot of people who want to transit into tech, you tell them that SQL is important, and mostly a lot of them don't want to write program. You don't want to do anything logic, but trust me, the most simple language is also what? SQL, right? So there's nothing to get worried about. You don't have to be a statistics student, or you don't have to have a degree in mathematics or degree in computer science to understand this programming language. Moreover, I studied computer science, and we didn't even, I don't think we were taught. You understand? So you can get it right. You understand? So this is word of encouragement for those that are just uh, knowing this for the first time, right? So let's talk about what is the this SQL itself. We have been saying SQL, SQL, SQL. So some people call it SQL. Whether you call it SQL or you call it SQL, we are saying the same thing. SQL stands for Structured Query Language. Mark that word. Structure Query Language. The language there simply means that this is actually a what? A programming language. And what do we call a programming language? A programming language is a language of the computer. The language you use in giving instruction to the computer, just the same way you have the human language. So what we are doing right now, we are communicating, and we are doing this using what? Human language. So that is the reason why we could understand one another. The same way too, when it comes to computer, you want to communicate with the computer, you do that using the language of the computer, and that is what we call programming language. Now we have different programming language in what today. There are so many of them, and SQL is one of them. But some experts uh, might not regard SQL as a programming language, but still it is a programming language. So just that SQL is a dedicated programming language, unlike the general programming language that we all know, like Python, like PHP. Those ones are general purpose programming language because you can use them for general purposes. But you see a programming language like SQL, this is called a dedicated programming language. I hope you guys have a pen and a note there. You can do some jots, you understand, so that I can read more about this online or after the class, please. So that is SQL. So it's also a programming language, but rather it is a what? A dedicated programming language. And this language is dedicated specifically to be able to access, manipulate, and retrieve data from the database. You can see that. So this is a kind of programming language that has been dedicated for specific use, and that use is to be able to manipulate, access, and retrieve information from what? From the database. So what is the database? So a database, we must know what a database is as well. So if you look at the word database, is a combination of two words. You can see data, and you can see what? You can see base. So when we say data, we all know what data means, like a raw fact, and base, like a base, like an house. Let's use that word, like an house. So which means that the house where data is stored is called what? A database. Am I communicating, guys?
Yes,
All right. So that is what a database is. An house, something that, or let's say something that house data, just like you have an house over you right now. So you also have an house for this data. So where these data are stored is called a database. So that left you to wonder that, oh, so if we say a database are places where data are stored, does that mean things like your flash drive are also a database? Does that mean things like your hard disks are also a database? Because obviously we use them in saving what? We use them in saving data. We use them in saving data. So because anywhere you store your data, we can regard them as what? A database. I will say yes, and I will also say what? I will also say no. Because obviously you know we don't call flash drive, we don't call it a database, even though we store data there, but we don't call it what? A database. Because if you look at a flash drive as an example, that device stores different kind of data. You can put an Excel file inside it, you can put a video inside it, you can even put your images and any kind of file, you can put it in a flash drive. But this kind of database we are talking about, it stores data that has a particular structure. This database we are talking about in this context now, not in any other context, in this context, of the data space, like data, or as a data analyst or data scientist. When we talk about database, everyone in that field understand this kind of database we are talking about is an house for a specific structure of data. And what are those structures of data? We can have different structure. So when it comes to data, we have what we call a structured data, we have what we call unstructured data, and we have what we call what semi-structured data. So when we say structured data, these data are what are in a tabular form. Everybody see this data every now and then. If you have used an Excel sheet before, data in an Excel sheet are represented in rows and columns. Those are what we call what structured data. Any data you can see being represented in rows and columns, these are regarded as what structured data. We also have what we call unstructured data. These unstructured data are refers to things like your images, like your videos. These are what unstructured data. They don't have a specific structure. You understand? And we have what we call semi-structured data. You understand? We also have semi-structured data. Semi-structured data most of the time are combinations of both structures and what and and the unstructured data. Most of the time it's usually combined, but that is not where we are going. So we can dive more into this explanation, but not to take too much time. So basically, we have some certain database that store structured data, and we have some certain database that store unstructured data, like a JSON, like XML. And we also have some database that also store what semi-structured data, as the case may be. You understand me? So that is what a database is. Any question, guys? Please, this session is meant to be engaging. For those that know me before now, I love interaction, so feel free. It's an open class. I don't mind even if a concept is being explained and you feel like, oh, I think you had something to add to it. It's fine. It's fine. Nobody's an island of knowledge. Feel free to ship in your points of view. Is that understood? And if there's something you don't understand, let me know. We can get it more clearer. Is that understood? So when we talk about database, so that's why you have this little diagram here. If you look at the database itself contain schemas. So schemas. So you can have one or more schemas within a database. Alright. So and within the schemas you can have tables. So this database we are talking about here is a kind of database that stores structured data. And this database that stores structured data are refers to as relational database. So data in this relational database are usually what in tables, and these tables are made of what rows and columns. You will see that as we move on. So back to the SQL programming language itself. So the language are divided into different categories. We have some part of this language that are referred to as what DDL, data definition language. Data definition language. Pay attention to the word. I might not necessarily have to be explaining what they are, but if you pay attention to the word, you will understand the meaning from there. Data definition language. That means certain command which are used for defining new data. So that's why we call it what data definition language. We also have some command which are what data manipulation language. Some are used for what manipulation. We also have what transaction control language. So these are commands that are used for performing transactions. So you can see some example of them there. And we have data control language, which are used for controlling data and objects within a database. Is that understood, guys? Okay. So I've explained what database is already. A database is an organized collection of.
Sorry, sir. I'm so sorry to interrupt.
Okay, go
I
ahead.
can't see your screen now.
You can't see my screen.
Yes.
Uh, Please, can someone else confirm this? I'm sharing my screen.
Yes, I can see your screen.
All right. Please,
Where is the network?
all right. I've been bad. Please, can you log out of the session and join in again? It must be your network. All right.
Bishola, please, can you display the previous screen? Let me just make a screenshot,
Oh,
please.
okay, okay. That's fine. All right. So if you want to make a screenshot, you are fine to do that because forgive me, I won't be sharing this slide, please, just in case anyone care to ask. All right. Okay. Is that fine, guys? Any questions so far? So like I said, this today's session, don't be too optimistic. Today's session is all about understanding core concepts. You understand? We will learn about the program later on. So if you like you understand all this already, yeah, it's fine. It's fine. You can even contribute into what I'm saying now. Is that understood? Alright. So we've talked about database already, and I've told you that we have different types of database. We have what called relational database. These relational database are used to store what structured data. So when you hear relational database or you see relational database, this database store data in what? In tables, rows and columns. Rows and column. Example of those databases are what? MySQL, MySQL, Postgres, SQLite, and so many more of them. So I think now at this point, some people might be wondering. So there's actually a difference between SQL and MySQL. So if this is your first time knowing this as well, you are right. So there's actually a difference between SQL and MySQL. SQL is a programming language. MySQL is a what? Is a relational database system. There's a relational database system. So there's a difference between them. Just that this guy, the creator of MySQL, decided to use the SQL. I don't know. I think it happens to be the first relational database that was created, and I think he joined this together with his daughter's name. So to have MySQL. All right. So, but after there we have databases like Postgres, which is also a very popular database, and we have SQLite, which is also a very good database as well. So many of them that I can't remember right now. And we also have NoSQL databases too. These databases stores data in what? Most of them stores data in JSON format, like MongoDB, Cassandra, DynamoDB, and so many more, like Redis, and so many of them. So these are NoSQL, and NoSQL stands for what? Not only structured query language. Not only. So it means that this kind of database, it uses a language called not only SQL, no SQL, right? So there's also something to also learn from that too. All right, there are some databases that are also on the cloud. So you can have cloud databases like Google BigQuery, like AWS RDS, and so many others. This kind of database, there are also databases too, but they are sitting on the cloud. They are sitting on the cloud. So I believe everybody understand what we mean by cloud here. Is there anybody who does not understand cloud here? It's not the typical cloud though. Am I communicating? All right. So we also have some databases called flat file database. Some people regard this as a database. So flat file, right? And most especially, this is what the CSV files. So we all see CSV file every day. So CSV files stands for what? Comma separated values. Is that understood? Is that understood, guys? Any question? So we are moving on. Any question? All right. Thank you very much, I'm your person. Okay, if there's no question, so does that mean I can ask a question, right? So let me look for someone. Let me look for someone. Don't hide your face, so. Uh, Kashifa Balogun, are you there? Kashifa Balogun, are you there? Okay, I think he or she is not there. Collins, are you there? Divine Collins, are you there?
Yes,
All right.
yes,
Thank you very much. So, can you tell us from your own point of view, what you have gathered tonight? Can you tell us the difference between SQL and MySQL?
I think SQL is a programming language,
Okay,
then MySQL is a database, a relational database.
a relational database. All right. Everyone supports Collins, right? Okay. Okay, I agree with you too. I agree with you too. All right. So, but I think let me chip in one or two
Sorry,
things.
that
All right. You want to
I
say
don't.
something? Uh,
Sorry, I want to clarify something. So,
okay.
okay, so it's a programming language, right? Yeah, but then, earlier, then then you taught us that it's a query language. Now, what's the difference between a query language and a programming language?
Okay.
Like, isn't it easy, or is there any,
Yeah, yeah. I don't know why you want to put me on the spot now. All right, it's fine though. All right, so she's saying is there a difference between a query language and a programming language? And my answer is what? No. You know, earlier I said a programming language is a language that's used to what? To give an instruction to the computer, right? And I say this programming language can be into two. You can have a dedicated programming language and you can have a what? A general purpose programming language. General purpose programming language are things like what? Python, Java, PHP, which can use them for creating things like websites. You can also use them for data analysis, right? But when you talk about SQL, SQL is a dedicated programming language, which specifically is used for what? To query the database. So that's where the word query language comes in. So if you call SQL a query language, you are right. If I also call it a what? A programming language, I'm also right. Is that understood? So that's where the word query language comes in because we use SQL to query the database. So when you query the database, what do? You can query the database to actually do what? To actually manipulate the data within the database or to retrieve data from the database or gain access to the data in the database. So all of these activities you do on the database with SQL, you do it by writing query. So the command that you write is what is called query. Is that understood, Doris?
Yes, sir.
Uh,
So it's safe to use the word interchangeably, right?
yes, yes. You can use interchangeably. If you like call it query language, if you like call it programming language. I believe anyone on the field will understand what you mean.
All right.
Okay, thank you very much. Okay, so but it's nice to also add something to make this whole understanding very easy. Now, because let me make a little illustration here so that what's the time? So we can work with time. Okay, so let's make a little illustration here. Now, for us to understand is very clear. So now, since we talk about SQL to be a programming language, so let's assume I have SQL here, which happens to be a programming language. Now, obviously, as a user, as a data analyst or a data scientist that you are, your own is to understand this command, to learn about this command, so that you can able to query data. So, which means that your purpose of learning SQL is that you have a database somewhere. So let's assume you have a database somewhere. So this database can be any of these database that we mentioned right now. So if I have a database here, so it means that if you want to interact with this database, you must learn the language of what? Of SQL. So what you are doing here is that with this language, whenever you write a query, you are sending a what? An instruction to be performed on this what? On this database. So you write the language in SQL, and once you execute the code or you run the code, it send that as an instruction to the database to perform an activities for you. Just the same way, if I have a brother at home and I give that brother an instruction, do this for me. That's the instruction, right? So that is the same thing that's happening here. The SQL is written to give an instruction to the what? To the database, and based on the instruction you give, the computer perform the instruction, execute the instruction for you, and return a result back to you. So even though there are a lot of things going on behind the hood, but because of time, um, we don't necessarily have to like go into all of that. But just know that on the lighter note, you are writing an instruction which is SQL, and there's a database that stores data. So the query executes and then perform an operation on this database and return the result back to you. So it's like give and take. So you give an input, the program or the computer perform an operation on it and give you back an output. So that's all you need to understand right here. Is that understood? Any question, please? All right, can I get some emoji if this session is making sense and we are getting value, please? All right, thank you very much. All right, thank you very much. All right, so that shows that we are following. Okay, now let's talk about data modeling. So another very important concept that you need to also understand before even writing any code is for you to understand what data modeling is all about. And what is data modeling? Data modeling is about designing and building this database, because now you have an understanding of what a database is. It will also be nice for you to know how do you design that database. So you might be wondering, why is this kind of knowledge important to me as a data analyst, since my work is just to write a query into a database, get the results, and then make a report out of it? Or why is it important to me as a data scientist, since I just need the data in order to build my models or do some analysis on it? So you might say, "Ah, this should be the work of a, I don't know, you might think it should be the work of a data engineer or database administrator." But trust me, this knowledge is very, very important to everybody, either as a data analyst or a data scientist, or whoever you might be. So far you are learning about database, it's important that you also know how to design a database. Please and please, it's very, very important. Now let's use this database I prepare here. So if you look at this diagram that you have in front of you, so let's
Yes,
take,
yes,
please, can you log in and log out? I believe I'm sharing.
yes,
All
yes.
right. So look at this simple diagram I have here. So this diagram is called an entity relational diagram. We call it ERD, entity relational diagram. So it's one of the things I love doing actually when it comes to database, drawing things, right? So now if you look at this information here, at least if you cannot understand anything from this diagram, you will understand that I am storing different kind of data. Now this shape you are seeing here, this represent tables. This represent tables. So when we say table, picture your mind like, okay, oh, you have a spreadsheet. Just picture your mind like that, a spreadsheet. And you know that a spreadsheet have what? Rows and column. So imagine you have a store and you are keeping record of the sales data in a table. You have another table, you are keeping record of the products. You have another record or table, you are keeping the record of your customers and so many other data. So this is just like what? A different table that keep record of your information. Nothing more. Different table keeping different record. I have a table keeping only record about sales. I have a table keeping record just about products. I have another table keeping record only about customers. Now the question is, why do we have to put many tables like this in a database? Why don't we just have one table and put all the information or the data inside that table? Why? Why do we have to go through the steps of having many tables? Please, can you mute your mic? So that's a question. That's a question I'm asking myself now, and I'm asking my audience as well. So is there somebody who like want to tell us about this? Why do you think we have to have many tables and not just one table to put all this information? Why many tables? And
Well,
okay,
my understanding, I feel is like, okay, grouping them, right? So when you group them like that, it's easier to understand
okay,
instead of everything, yeah, together. So now if I want to, for instance, this one now, if I want to go to sales, I can just go there instead of
okay.
to, yeah,
Uh,
go around and looking for a particular thing.
oh,
When it's grouped, it's easier to locate everything.
okay. That's very nice. Thank you very much. Anyone else? Please, 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 please. Let's engage.
Okay, good evening,
All
sir.
right. Good evening.
Yeah, to my own just knowledge, I think the reason why we are creating tables, like we are modeling tables, is
Okay.
because we should be able to make informed decision
Okay.
from each table, and we should be able to link a particular table to another table. If there is any correlation between tables, be able
Okay.
to bring them together
All right.
and model them, something like that.
All right. All right. Thank you very much. Thank you for the contribution. Anyone else? Anyone else? This happened to be my least engaged class. What's going on? My sessions are always very engaging. Is it because it's almost December? People are looking for money. So, what's going on? Or we are tired because we just came back from work. Is that it? Mr. Ayomide Daudu. Are you there? All right.
Yes, sir.
Okay, Ma. How you doing, Ma? How was your day?
Fine,
I hope
fine, sir.
I hope it's not stressful. All right.
No, sir.
So what can you tell me about this? Are you not worried? Because I'm thinking, why don't we have all the informations in one table? Why many tables? Are you not worried too?
Actually, just came in now. This many things.
Okay. 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 No problem. That's understood.
Yes, sir.
All right. Anyone else? Divine Collins. Moyolua.
Like just to add to what other people said,
Okay.
like if you had only one table,
Yeah.
it will be very hard to query the database.
Okay.
So it's better to split the tables into like
Different tables.
select yeah, different tables with
All
an
right.
identity.
Okay.
Then query them.
All right. Okay. Thank you very much, everyone that has contributed to this and everyone listening. You all are right. You all are right. But let's break it down to my own level. Let me say my level. You understand? Now, because I'm wondering that if I have all the data in one table, does that mean that if I lose that table, I lose all my information? Like business wise now, if I put all the data in one table, it simply means that if something happen and I lose one table, it simply means I lose the whole business, right? But having the data in different table means, okay, if like one of the contributors said, if I have the data being separated into different identity, it simply means that okay, I can easily recognize a table when I need an information, and it simply means that if something happened to one table, possibly the other tables are not what affected. So that is just on a lighter note. So but the whole reason for this is what divine callers have said, to make it easy for you to what to query that table, to make it easy. So there's something we call normalization and denormalization. So that's another concept I want you guys to read on. Normalization and denormalization. So when we say denormalization in the concept in data, denormalization simply means that you have all your data in one table, and we see a lot of data like that. You pick an Excel sheet or a CSV file, it's just one table. It's not bad. It's not bad. You understand? But that kind of data is what is not denormalized. You will start seeing informations of you start seeing multiple informations in one table, and this denormalized data have some problem. Some of the problem they have is you have redundancy. You have some anomalies like updation anomaly, insertion anomaly. You understand? There are so many anomalies that comes with having your data in a what in a denormalized setting. But with the help of a database usually stores data. It's best that you store your data in a database in a normalized format. You normalize it. So the attitude or the activity of normalizing this data uh is what give what we call a data model. So when you see a data model, it simply means that that particular data has been normalized. So we apply what we call the first normalization, second normalization, third normalization, there's fourth normalization, there's fifth normalization, right? So, but most importantly, once you understand the first, second, and third, I think it's okay. What is the first normalization? The first normalization is that you look at a business and you want to represent that business in a database. You understand? Somebody walked to you, a client walked to you and said, okay, I would like to be storing my business in a database. You want to be keeping record of your business in a database. You look at that business setting. You identify entities in that business, the most important entities in that business. Like for example, in this my little business here now, some important entities are what I keep record about my customers, I keep record about the sales, I keep record about my products. Identifying these entities are what will give you different tables. So if you can recognize these different tables, you have done what? You have done your first normalization. You have done your what? You have done your first normalization. Your second normalization talks about you identifying primary keys. I think I have a slide on that too. Okay, very good. So look at this. So talking about the components of data modeling, there are basically three. We have the entities, we have the attributes, and we have the words relationships. So when you talk about the entities are usually in noun. I remember when we're being taught in school then. So your entities are usually in noun, like in noun, like a noun is a name of any person, animal, place, or thing. That noun. So when you see those entities that are usually in form of a noun, like for example, a customer, you want to keep record about the customers. That customers is an entity. It has to be recorded as a what? As a table. Product is an entity. Your cat can be an entity. Can you also give me some example of what you think entity can be? Transactions can be an entity. Anyone? All right. Okay. So you can have different entity that way. You get. So looking at those entities, the entities also has what? Attributes. Attributes. So the attributes are like the field that will make up this column. So take note of that. The attribute are the entity. So like for example now, if I'm keeping record about my customers will have their name. You can have their first name. You can have their last name, their address, their phone number. Information you want to keep about that particular entity must be also be available. You understand? So moving on, you can also add the what? The relationships. You can have the relationship. The relationship here is how you decide the relationship between those two words, between one or more tables, like putting the primary keys. So, and the primary keys simply means what? The field on that particular table that we will use to uniquely identify the record in a table. So these are the major components that make up any model. You have the entity, which is also called a table. The table must have what? Attributes, which will make up the columns. Then there must be a relationship, which we'll talk more about later on. So you can have one-to-one relationship, one-to-many relationship, and many-to-many relationship. We'll see that in a second. Now, this your modeling we are talking about can either be a conceptual data model, a logical data model, or a physical data model. So we have what is called a conceptual data model. So when we talk about conceptual data model, this is a point where you realize or when you identify the what? The tables. So if you look at my diagram here, I have what? Just four entities. I have the product, which is where I'm going to be keeping record of the customers or of the product. I have the customer, which is where I'm going to be keeping record of my customers. I have the sales. So informations in a database that you perform a data model on, information there are actually what? They are actually created in such a way that they are they are separated from one another. There's something called separation of concern. They are separated from one another. You don't mix the information of the product with the sales. You don't mix the information of the sales with that of the customer. And this is what we call normalization. This helps us to eliminate things like redundancy in your data. It helps us to eliminate anomalies like insertion anomaly, deletion anomaly, or updation anomaly. So normalizing your data is a good practice. You understand? And sometimes I've happened to work on a project that you have a data is not being normalized, and the first thing you have to favor do is to normalize that data. You understand? But you have to like at least there must be a reason for taking that action. So probably to make it easier or more efficient for that business to be represented or in order to better optimize your database. So you can do that. So separating this data into their different tables make it very easy. You understand? So once you identify the different entities that make up this table, this is what? This is the conceptual data model. It gives you the high level picture or high level view of that database. Mr. Amayowa, please can you mute your mic? All right, thank you very much for that. So is that understood? So moving on, we also have what we call what? We also have what we call logical data model. So after you've represented your conceptual data model, your logical data model, this help you to specify the attributes and the relationship. So if you look at the information here, you can see that in my product, I have the product ID, which is going to be an identifier. This is called the primary key. So when you have an entity within a database, it's important that it has a primary key. Every table in a database must have at least one primary key. Best practice must have at least one primary key. Now you have other attributes like the name of the product, like the category, like the user unit, like the color, like the rating, like the description, information you want to keep about the product, and so many other things. You can see the other customers too. Information about the customer. There's also a primary key which is called the customer ID. Then you have your sales too, that has what? It has a customer ID, and it also has what? A product ID. In this case, the customer ID here and the product ID here is a what? Is a foreign key. So we understand what a primary key is. A primary key, it's used to uniquely identify a record in a table. Like for example, in a school, we have what we call the matric number. The matric number is to uniquely identify every student, because it's possible that in a department within the same faculty you can have two students of the same name. Coincidentally, they can be of the same age. Coincidentally, they can have every information, like there's possibility that they can have every information in common, but they will never have the same matric number. So that is why in every table we usually have what we call a primary key, so that whenever we want to uniquely identify the information in that table, we do that using the primary key. Why the foreign key on the other hand? The foreign key is used to establish a relationship. This is where the relationship now comes in. The work of the foreign key is to establish a relationship between two tables, because obviously you've separated the informations in your business. You've separated it into different table. You have the products in one side, you have the sales in one side. So when a user perform a sales, or when a user purchases something, that transaction will be recorded on the sales. But who is the customer that make the purchase? You don't want to record the information of the customer on the sales table. It must be in the customer table. But whenever I want to make a reference to the customer who made that purchase, it's done using the foreign key. And that is what the work of the foreign key is doing here. So it means that if I pick a sales record in this table and I want to know the customer associated to that particular sales, I will use the foreign key there, which is the customer ID. So with this relationship now, it means that when you pick a sales, you can know the customer who ordered for the sales, and you can also know the product that the person ordered for, and you can also see the date too. I can also know the date that this particular transaction was performed. You can see how this is related. So your data model give a representation of the business. If you get it right, you get everything right, and if you get it wrong, everything you get it wrong. So it's a very very important skills that we must have as a data analyst or a data scientist. You must be able to you must know data modeling. It's very very important. So now talking about the relationship, we have what we call one-to-one relationship. We have what we call one-to-many relationship, and you can also have what many-to-many relationship. So like for example, I think I have.
Sorry, Mr. Ola.
Okay.
Sorry. I know that creating the database, I know that primary keys and secondary keys can be confusing sometimes.
Okay.
So, but then, if you're using a secondary key, that means you have to reference the primary key.
Yes. Yes. So let me talk more about that in case people have question about that as well. So what she's trying to say is this. So if you look into every table, like for example, at least if you look at the product has a primary key, which is product ID. So the product ID. Now this product ID is related to the product ID in the sales. The product ID here is a primary key. The product ID here is a what? Is a foreign key. So by the time we load our data into a database, you will understand this more clear. I'm going to show you all of this. So it means that if you pick a sales here and that sales shows product ID 1, it means that that particular sales, what that person purchases is what? Product ID 1. So if you come here, that is where you will see the information about that product. So that means you will see the name of the product the person purchased, the category belongs, and the price. So when you have a primary key, you definitely will have a foreign key to establish the relationship, a reference between those tables. Is that clear, everyone?
Yes,
All
yes.
right, thank you.
Yes, exactly.
Yes, yes.
Okay, I get.
All right. Okay, I mean, thank you very much. Please and please and please, if this is your first time uh knowing about all of this, don't be shy. This is something I usually tell people a lot. If you are learning, don't be shy about your learning. Nobody, if you all know it all, we won't be here. You understand? If you all know it all, we'll be here. So the problem most of us have is that we are always shy when it comes to knowledge, and I'm not surprised because it also happened to me too. In my second year university days, I don't like asking questions. You understand? I don't, because if you look as if everyone understood it and I don't understand it, you get. But I don't know how we develop that kind of attitude. Probably I don't know. It could be cultural background. It could be own background. I don't know. So, but these are things that you need to let go when you are learning something from somebody. You get, try and be open. You understand, most especially those that you have not know this before, you don't know about this. And I know some of us ask question, you have question. I've taken student before, and they will ask you some questions like, why is this thing like this? So when you see those kind of students, there are some that are very inquisitive, they want to know everything. And this is a very important skills in this field, being inquisitive. You want to, like, why is something like this, why is something like this, why is not like this. If you are not inquisitive, trust me, to survive in tech will be a little bit difficult. You understand, you don't ask question, because what you do as a data analyst actually is that we ask questions. We ask questions on data. If you don't know how to ask questions from people, how then do you ask questions from data? You can see how this look. All right, Torimo, forgive me if I pronounce that wrongly. You want to say something? Okay, I think that's it. I believe that's a mistake. So please, so ask questions. You understand? It's a very important skills. There's something called soft skills and hard skills. So there are some skills that you get, like the one we are dealing with right now, learning sequence and hard skills. The soft skills at times is much more important than the hard skills. You might be able to write the best language on earth, but if you cannot understand the concept behind it, you cannot tell the story. You cannot do what we call data storytelling, which is another skills that you must have as a data analyst. You must be able to tell story. You must be able to give report of what you find in that data, because the data itself will not communicate itself. It is you that will find a way of communicating the data to people. You understand? So feel free to ask question. Torimo, please, you can go ahead.
Okay, good evening, sir. Can you hear me now?
Yeah, good evening, ma. How are you doing, ma?
Yeah, thank you so very well. Thank you. Thank you
Yeah.
so much for this. I want to ask that would the recording be made available?
Yes, immediately after the class, by God's grace.
Okay, what platform are you going to be sending it?
I'll upload this on YouTube.
Okay,
Yeah.
okay. Thank you so much.
All right, you're welcome.
Thank you. I really think it's a fantastic
Uh,
one.
uh,
Thank you.
uh,
I'm enjoying the class.
all right, thank you very much. All right. Okay, let's move on, please. Let's move on. Okay, now to the logical data model. So, what do we do on the conceptual data model? On the conceptual model, on the conceptual data model, we identify the entities. Daniel, you can go ahead, please. Daniel, all right. Go ahead, please. Good evening, sir. Please, can you move closer to your mic?
Okay.
Go
I
ahead.
said I just want to ask a question. Can you hear me clearly?
Yes, I can.
Okay. Now in data analysis,
Okay.
must somebody be up to graduate level?
Okay. Is that your question?
That is question.
Okay, go ahead.
Okay. Question number two. The statistics presented, I think that determines a lot of things about the data you analyze.
Okay.
And most times we don't have the correct data. I think that I have a little experience in that aspect. I am speaking from experience.
Okay. Okay. All right. Okay. Thank you very much. All right. So let me start by answering the first question. So I think your first question is about, to be a data analyst, do you have to like have a degree, a graduate degree, to be a data analyst, if I'm correct? So I'll make this a general question, and how I'm going to make this general is that I will rephrase the question. Like, is it important for you to have a college degree or university degree to become a data analyst or a data scientist or a data engineer? So, and my answer is what? Capital no. Capital no. Capital no. You understand? I'm saying this again. It's capital what? Capital no. So you don't need any degree to learn a skill in our generation today. In our generation today, you don't need a college degree to learn a skill. You understand? So, and why did I say so? Let me use myself as an example. Even though I happen to study computer science, that doesn't mean that that is the reason why I'm here today. I will say this over and over again. I'm very sure that if I didn't learn data science, I would still be here. I have a lot of people on this call who didn't learn computer science. They didn't have any degree in IT. You understand? And now they are into data analysis and data scientists. I have friends who study biochemistry, medicine. They are into tech now. So to get into tech, you don't need any degree. You understand? You don't need any degree. Some of the things that you need is one, to survive in tech, you must be curious. You must be somebody who is hunger for knowledge. When somebody is hungry, like you have that hungry. I don't know, I don't want to commit blunder with this English. You understand? So like you are very hungry to learn, to get knowledge, because that's one thing in tech. You must be very curious, very inquisitive. You must like solving problem. You understand? If you have these attributes, trust me, you will survive in tech, and you don't need any degree. You don't even need any certificates. So, but there is some situation where certificates might now be, you understand? Some organization that you want to get a job there, having certain certificates might be important. So we can't remove that fact. You understand? So, like for example, let's say banking sector. Now, I've not worked in the banking sector before, but there are some structured organization that if you want to work there, you must at least provide one or two certification. You understand? Either at the university level, or you going to a boot camp. You going to a boot camp like Coda Tech Africa and getting a certificate in data analysis or data science. So those are cases where certificates might be important. But trust me, before anybody will request for your certificates, the first thing that we want to know is what? Do you have the skills? Do you have the skills? Do you have the skills? So, and the only way you can show this is by your portfolio, what you have done with that skills. You get? So in this field, skills is supersede your certificates. Your skills supersede your certificate. There are some people that have certificates in computer science, and they can't even write a simple SQL code. So it's not about the certificate, it's about the skills. So I hope I answered the first question. So don't let certificates be, or a graduate degree be, your restriction. Don't let that limit you. All you just need to take is engage in a boot camp. You understand? When you engage in a boot camp 3, 4, 5 months, then you're able to get one or two skills. Then you get started. And your second question, I think I can't remember that. Please, can you remind me?
Okay. What I asked, thank you for the first answer.
Okay.
The second question was, now in Nigeria,
Oh, I remember now. Sorry about data, Abi.
yes,
All right. Thank you very much. So this is a major concern to every data practitioner. I would have loved somebody to give you answer to this, but let me see if the person is still on the call. I don't want to bring the person to, but let me see if he's available to talk to you guys. So if somebody you benefit. Okay, I think he left the call already. All right. Okay, no problem. So I will answer to that. Okay, so back to your question. talking about data. So this is a major challenge actually to every data practitioner in Nigeria. So having quality data is a major challenge. Even though the country, or let's say Nigeria, the federal government they have a database where they are keeping record. I think they call it I've forgotten the name. So they have a repository also, just like the way you have repository like Cargo, US Open Data. So Nigeria to also have uh, a repository too where they keep their data. So I don't know if anybody know that on the call. You can help us with that. So Nigeria have it, but where I'm going to is that we have issues that this data, even the one the federal government even are making public, you will look at it, is nothing to write home about. And what is the problem here? The problem here, to me, what I see here is lack of transparency. Our government are not transparent enough to make data public. Even the private one that call themselves private organization, let's even assume a private organization might be restricted because it's actually a private organization because it's created majorly for making profits. But to me, I will even tell you that even the private organization are doing better than the federal government themselves. We have some private organization that their own responsibility is to make data available for people. So I don't want to make promotions for people. I know of two, three companies that do that. Their own is to like gather data and then make it public for people. You understand? We have done something like that too in one of my classes with students. We generate data and we make it public on Cargo. You can check that on Cargo. Together with my student, we've done things like that before. We've gotten data of houses in Lagos State. We've gotten so different like data. We get it and we make it public for people. You understand? A lot of private organizations too are also doing this, making data available. You understand? So just that we don't have more people into this field. So if there's any, if you are an investor, you're an investor and you like want to go into anything, I think one of the places you can put your eye into now is investing to into this kind of sector. Because right now we don't have much people there, and there's need for it because data in Nigeria is not is nothing to write home about. I will even tell you categorically that if I want to get Nigeria data, I trust getting it from other country platform like US. Imagine how that is. You want a Nigeria data and you can still even get a reliable source from US platform than Nigeria platform. That is how bad this. So this is not a problem of data scientists or so this is like, let's say, I don't know, this is like a um uh should I call it a, I don't know the right word for this. So it's like a, it's like our country kind of a problem. You understand, which can actually be solved if government are more transparent and they are able to like give us this information because there are a lot of information you can make from getting this data. You understand, health information, all of these they are make available. So you don't restrict people by creating laws and all. Even though I know data need to be secure, data need to be secure because the way you are thinking to do good with that data, if that same data get to the hands of bad people too, they can also do some other things with it. Aha, so let's also take note of that. So I think that problem is a major problem and a lot of people are looking into this. I remember in one of my conference I attended last time, this was also a major problem. You understand, but trust me, there are some companies that I don't want to mention right on this platform. There are some companies doing that right now, that's giving you available data. If you search online, you see some of those data. We now have research institutes that are doing all of this just to make this a better space for Nigerian data. All right, I hope I answer your question.
Yes, thank you
All
very
right,
much.
all right, you're welcome. Okay, so I think that let's go back to the class. So we talk about the, okay, Stanley, you want to ask a question too? Please go ahead. Please go ahead.
Okay, I thank you. I heard you mention that one can invest in the data collection of data.
Yeah.
So I wanted to know how that is profitable or how one generates money by just collecting data.
don't worry. Come and hire me as a consultant. Yeah. So maybe you chat me up after the call. So if you want to talk business, it's not understood, but it's actually
Ah,
possible. So we can talk on that later on.
okay,
All right. Thank you very much.
okay,
Any other question?
okay.
Uh,
So, are you dropping your number
yes.
or am I meant to
Don't
call you?
worry. We will link up. Don't worry. I think I can share my LinkedIn profile,
Okay,
so at least we can
okay,
connect from LinkedIn. So just remind me before the end of the class. Okay, so let's get back to
okay.
business. So still on the data modeling, we talk about conceptual data model that has to do with identifying the entities. So and then we talk about the logical data model, which has to do with putting the fields, and then the last one, which has to do with what putting the field, putting the data types rather. So we have conceptual data model, we have logical model, and we have the physical. Okay, I think I missed that. So this is meant to be the physical data model. Sorry for that. So this is conceptual data modeling. This is logical data modeling, putting the field, and the last one is what, the physical data model. So the physical data model is when you put your field, like their data types. So you can see that my product ID here is an integer, the name here is a varchar. So all these are data types. So varchar means variable character, so we use it in storing strings data in a database. So we also have data type like date time, and so many of them like this. So if you can put all of this together with the relationship, you have this diagram, which is your data model, and this diagram is called what, entity relational diagram. Is that understood? Okay, so that is that for data modeling. Now when you look at your table, so these are another important information that we also need to understand. After you've put your data modeling like this, so we have different tables like this. So there's something we call the fact table. So these are interview questions. So when you go for an interview as a data analyst or a data scientist, so you might be opportune, they might ask you questions like this, so around data modeling. So when you make your data model, there's something we call the fact table, and the fact table is usually the words, like the transactional table. So it's usually the transactional table. To understand this table is like, out of every table, this table is one that change frequently. So that's why we call it transactional table. This kind of table change frequently. Like for example, to understand this, if I go back to this data model, now if you look at the product, the customers, and the sales, and the date. Now when information get to this table, like how often do information get to this table? How often? Now you information does not necessarily have to get into the product every seconds. Informations, you will not be inserting information into the product table every seconds, because as a company you probably have the product you are selling. Let's imagine you have a company that sells 3 products. You can't tell me that every second they are going to be adding a product to that table. This kind of table probably will accept an input or a data maybe once in a year, or even once in 2 years. If they are not adding a new product to their catalog, that means they might not even be adding any product. The same thing, customers don't get sign up into a platform every seconds. It's not possible. You understand? So information in the customers doesn't like change frequently, like every seconds like that. Same thing happen to the date. But you look at the sales. The sales here is actually the transactional table, because every seconds there's possibility of these sales getting an input, because the idea is that every customer can make what, we need to make a sales, and when they make that sales, the information will be recorded into the what, into the sales table. So this sales table change often more than every other tables. So that's one way to identify your fact table. You understand? And most of the time this fact table usually contain what, numerical values. Numerical values. Now the other kind of table that you need to understand is the dimension table. The dimension table on the other hand describe the fact table. You can, this one is easier to understand. When you say dimension table, the dimension table describe the fact table. Like for example, going back to this ERD, if you look at this, product is describing the sales. You understand? The same thing the customer too is also describing the sales, telling us that okay, this is the product the person bought. The customer is telling us that okay, this is the customer that make the sales. The date is also telling us this was the date that the sales was performed. So every other table here are describing the fact table. So when you see a data model, it usually contain a fact table and multiple dimensions. The fact table are usually one, then the dimension can be what? Can be many. Am I communicating, guys? Am I communicating, guys?
Yes, please.
All right. So talking about relationship, so you cannot talk about relational diagram and not talk about what? And not talk about relationship. So if you are a data analyst or a data scientist or a data practitioner, this will usually be the relationship you want. Everybody wants this kind of relationship, right? Want the kind of relationship you can hold hands with your partner and all of that. But luckily for us, this is the kind of relationship we get. Is that not interesting? Who prefer the second relationship more than the first one? Anyone? You people are quiet. Why are you quiet? So I thought we all love this relationship. In my case, I love this relationship more than this relationship. If you are wondering why, you can chat me up later. This relationship does not give you problem. This give you problem. That's me anyway. Alright. So that's just an lighter note. Alright, so talking about the relationship. So you can have one-to-one relationship. So when you say one-to-one relationship, you understand? It means that this table, this record here can only appear on this record here like one time. Like, let me give you an example of a one-to-one relationship. Like imagine you have a table for payments. You have a table for payments and you have a table for customer. Customer will be making payments. So by that business requirement, customers can make payments. By that business requirement, as a data person who is creating a database or creating a data model, you know you can identify two entities already. So people can relate to this. Let me put it on the screen. Customers can make a payment. At least on any platform you can make a payment. From this statement alone, you can see that I can identify what two now. This way I know that I need an entity to keep record of the customer and I need an entity to keep record of my payment. So if this is a table and this is a table, what will be the relationship that will exist between these two tables? So we have a payment, we have the customer table and we have the what? We have the payment table. So this guy, so let's say customer, so forgive my illustration please. So just kindly pay attention to the detail. So if I have a customer table and I have a payment table, so because we talk about having the columns, so obviously you have what we call customer ID here. So this customer ID here within the customer table will be a what? A primary key, because I need to uniquely identify this guy. So the same way you can also have a what? A primary key here, and this primary key on the other hand will be a what? A payment ID. Now, but for you to be able to know which payment make a payment, what do we need? I've represented my entity. This is the table and this is the other table. But these two tables cannot just sit down like this. They need to be related. And that is where you need what? You need your foreign key. So we need a foreign key in order to establish a relationship, a reference between these two tables. So where can I have my foreign key? Where can I have my foreign key? Somebody please. 827.
In the payment table.
In the payment table.
Payment table, you can have your foreign
Yeah, exactly.
Customer.
All right. So that means we need a foreign key here to establish that relationship. Customer ID. So this guy will be a what? A foreign key. Now to be able to establish a relationship between these two guys. So, but what kind of relationship will now exist between them? Can one to one exist between them?
Is it one to
One to
many?
many.
All right.
One to many.
One to many. Everybody say one to many. All right. So this happened to be one of our one of the things that we look at into one of my classes, and this raised a lot of debates when I was in class that day. So some students say one to one, some say one to many, and luckily everybody is actually right. So when you say one to one, you are correct. When you say one to many, you are also correct. And this is where the understanding of the business. So we don't just do things as a developer.
Excuse me, sir. Excuse me, sir.
Okay, good.
Please, sir, for the YouTube channel, you said we posting it on. What's the name of the YouTube channel?
Don't worry, I will communicate that, sir. Don't worry, I will
Okay, sir.
communicate that.
Thank you, sir.
All right. So now, if you look at this can be one to one. How can it be one to one? In a case where a customer can only make payment once, you can only make payment once. You purchase an item, you can only make a payment once. That can be one to one. But in a platform whereby you can make a payment maybe multiple times using different channel, you understand? Maybe you can decide to say, okay, I purchase an item, let me pay a 50% of the payments now. Later on, I'll come and make the other payments. That can be what? One customer can make a payment multiple times. So that can be one to many. You understand? But in a platform whereby the customer can only make the payment once, and once they are make the payment, that is it. So that can be both one to one. So there are also many other examples. There are some platform that between the customers and account creation is just one to one. When the customer creates an account, you can create two accounts. That's another example. Between the customers and account creation, some platform can only create an account once. So that means your profile must not appear two times. Is that understood? So that is the case whereby you can have what? You can have one to one relationship. You can also have many to one or one to many in any case. Like for example, between the customers and the sales, there's one to many. You understand? If you look at it from here to this other end, is what? Many to one. And you can also have what? Many to many relationship. So these are the relationship that we have within what? A data modeling. So, and that takes us to the case study we are going to be looking at. So like I told you, this is not just going to be theory, this is going to be like practical base. So but we need to set the background, the fundamentals, so that everybody can understand this. So we're not just about writing the code. So at least in this code now, you understand what is SQL, you understand what is MySQL, you understand what we mean by a database, you understand the kind of information or the kind of data a database stores, and you understand how to query or get a data or an insight from a database is by communicating with that data using SQL. You understand what we call data modeling a data within a database, and this is the case of a project that I want us to look into. So we are going to be using the next 30 minutes to design a data model, just that everybody understand how this is being done. Are we ready for this, guys? Any question before we move on to the second part of this class? Kindly ask any question, please, regarding what you have learned, or you want to add something to this. Is permitted, please. Okay, if there's no question, can I get some emoji? Can I get some emoji? So that's give me a sign of relief. All right. Okay, thank you very much. All right, now let's do a data model. Let's do a data model so that everybody understand how this is being done. Okay, and there are many platforms you can use for this. There are many platforms, but I'm going to be using draw SQL. So there are many platforms you can use. There is what we call draw.io. So if you are online, just go to this platform, draw sql dot app. So you might need to create an account if you want to follow now or maybe later. So there's also draw.io. We also have lucid charts. So lucid chart, there are so many of them, but these are the few ones I can remember right now. So and these are important tools for you too. So now we're getting to the tools. Now all I need to do is create an account. So I already have an account with these guys, draw and you can go to your diagram. So your okay, just click on get started. I can log in with your Gmail or so. So I'll go to my diagram. Okay, so it takes you to your database diagram, and you can see all the database diagram you have so far. So in this case, all you just need to do is to click on what's new diagram. So you click on new diagram, and you can give your diagram a name. So this database you are creating is about pizza, so I'm going to name it pizza erd. So that stands for integrational diagram. So you have your diagram visibility, so you can make this public or private. So if you want to make your diagram public, it means everyone on the internet can have access to it. But when you make it private, you need a pro account to make it private. So but you can go ahead and make use of the public version of it. Then you select your database type. You can see there are different database type here. We have the MySQL, we have the Progress, and we have the SQL Server. So since we are focusing on MySQL in this class, so we're going to be using MySQL, and I'll say create diagram. Alright, so then this sets up a Canva where you can design your tables. Okay, so now looking at this, so this is our target. So I have different tables here. So the first thing I will do is to create the entities first. So I create the orders table. I have the orders details. I have the pizza, and then I have the what? I have the pizza type. And I think let me go ahead and because I can see that this table is hiding some of the information. Uh, so just give me a minute, please. So just a second. So we can have all the information that we're working with.
Hello, Mr. Ma.
Yes, go ahead, please.
Hello, Mr. Ma.
Yes.
To this quick one, I just want to brief you about a bit about when we were talking about the fact and dimension table.
Okay.
Can you hear me, sir?
Yes, I can hear you.
You said something about the fact the dimension that this correlates the dimension or something like
The dimension described the fact table.
describe the fact table.
Yes.
I said the fact is often numerical, right?
Yes, and it's usually transactional. It's usually transactional.
Okay, all right.
So that means the word transactional means information gets to that table like frequently. It changes often. It changes often. All right.
All
Uh,
right. Thank you.
all right. Any other question? Any other question? All right. No question. Okay, no question. All right. So let's get into this. I'm trying to see if I can put a better diagram that is going to just give me a second, please. Please, you can go ahead and ask your question. Feel free to ask your question, please. apologies, please. I didn't see this coming. Okay, I think we are good now. All right, so let me share my screen back. So let me know when you can see my screen. All right, I believe everyone can see my screen. All right, thank you very much. So I just wanted to open the diagram on another device, so I don't have to be switching the screen. All right, so all this will be provided for you already. So immediately after the class, I will give you all these resources. All right, so on this platform now, so once you get to this platform, the first thing you need to do after giving your diagram a name, so you don't have to worry about saving. This automatically save into the internet on the cloud. So the next thing I need to do here is to give my table a name. So you can start by creating your tables. So I'll start by creating my tables. So I'll say new table. So when you create a new table, you can say that this appear, this says table 1, and I can edit my table by clicking on this guy, and I'll give my first table to be, let's say, orders. So orders. So I'm going to be asking a lot of questions here, so please kindly pay attention just for you to know to to be able to check what you have learned so far. So this become my table name. So I'm going to put the columns. So columns that is needed here are the, I think, the order ID. Seconds please. Oh no. So I don't want to be switching my screen. Yes. Okay. I think this is better now. Alright, so let's start with the orders. So for the orders, we have some columns. So we have the order ID, we have the order date, and we have the order time. So I think that is also visible here. So if you look at the orders table, so we have the order ID, we have the orders date, and we have the order time. So these are the columns that make up that particular table. So all you just need to do is to type in those columns. So order, I prefer to always start with the primary key. So order ID. So this order ID is going to be in what data type. So this can be in integer. So you see different data types here. So you don't have to worry about all the data. So they are just data types. So for example, you see integer, you see big int, you see medium int. So just see it as different sizes of integer basically. So here I'll be using integer, and this is going to be my primary key. So you can see that I can make this a primary key by adding what this, by clicking on this key here. So that make me to add it as a primary key. You can see this make it a primary key, and by also saying this nullable. So do you want to make it nullable? So in my case I don't want it to be nullable, so I mean I don't want it to be empty. So I think that is fine. So add columns. So I will add what we have, the orders date. So that's the date that the order was taken. So I'm going to be fast with this, and we have the order time. So that was the time that the order was taken. So this will be in a what, in what data type? The date data type, and this will be in time data type, as you can see. All right, so I have my first table. So you click on a new table again, and you have what, table 2. This time around I'll create the what, let's create the orders details. So that's another table that we have there, orders details. So I'll first rename my table. I'm going to call it orders, or let's say order details. Then you put your primary key first. I can call this order underscore detail. So your columns or your field name should not have a space, preferably. Preferably should not have a space. So you can separate that by what? Using underscore. I'll make this an integer. I'll make this a primary key. So it's already a primary key. Then add column. The next column is the order ID. Okay. And this is also going to be in integer since it's an ID. And we have pizza ID. So this is also going to be in integer. And we have the quantity that was purchased, and quantity also going to be in what? In integer. So quantity should be in integer. So we have this other table. Okay, so we still have another table, and let's create the what? The pizza table. So we have a table for the pizzas. Are you guys following me, please? Can I get some emoji? So pizzas table. All right, thank you very much. So all I just need to do, so if there's anything you don't get here, please ask question, please. Adeniji, one day, please go ahead. Please go ahead, feel free to ask question.
Please, I think good evening everybody.
Good evening, ma.
Please, I think I don't understand. Is this table you are creating is it the relationship table or the table we are supposed to create on the data? Is it are you
Yes.
creating the relationship table?
No, no, we are creating the table that we are going to build within the database. So we learned about data
Okay.
modeling now. We learn about data modeling. So we have
Yes.
a project to work on, and that project is about pizza.
Okay.
You understand? So since we are going to be creating a pizza database, it will be nice for us to create the data model for that database, so that we see how the data are
Okay.
related with one another.
Okay.
All right. So what we are doing right
All
now
right.
is data modeling. All right. So for the pizza table, we also have an ID for pizza ID. So which is the primary key, which is an integer. We also have the pizza type ID. Pizza type ID. Also, I think the pizza type ID. Uh, okay, we can confirm that later on. I think is a voucher. So we sell all that later on. And we have the size. The size, and that size is what? The size should be also be, I think it's voucher. So I'm going to show you all of this. So because I have seen the data already that we're working with, so I'm going to share that data with you, which your task tonight before the class tomorrow is that I will give that data to you, and you will go ahead and do this data model again, which you guys are going to share with me tomorrow. So we are not going home just like that. We go home with an assignment. So unit price. So my unit price, if I remember vividly, I think this is a float. So for decimal. All right. So this make the second column, and there we have another column, which is the pizza type. So I also rename that pizza types. So for the pizza types, we have pizza type ID, pizza type ID, which I think is a voucher. If I look into the data again, we have the name of the pizza, we have the category of the pizza, we have the ingredients of the pizza. So these are the information this guy are saving. So this is my voucher. This is also a voucher, and this is also a what? A voucher. All right. So I think that those are the columns, the tables we have there. I think they are just four. All right. I think we are done. Now, my question. Are we all there? Any question, please? Uh, Ms. Adeniji, any question, please? You are raising up your hand. Okay. Can everyone hear me? Okay, let's move on. So what I've just done here now, no, we talk about modeling. We said we have what? We said we have conceptual data model, we have conceptual data model, we have logical data model, and we have the physical data model. So from your own point of view, which one have we done here? Can you identify if there's any conceptual data model, if there's any logical data model, and if there's any physical data model? Is there anyone who want to describe these three things to us? Oh yeah, oh yeah, oh yeah. Should I call names? Miss Adeniji, are you there? Are you there? Now people are quiet. What's going on? Can you guys hear me, please? Can everyone hear me? I believe you guys can hear me. Munyoluwa, are you there? Abimbade, are you there?
Yeah, yes, sir.
Okay, thank you. All right, looking from this, can you tell me what the conceptual data model are?
Okay, the one with feet. Okay, I can say the pizza is a conceptual
Okay,
data model.
okay,
Okay, we have okay, we have our other details.
okay.
Okay, and same again.
Ah,
And pizza type too.
pizza type and the others. So you are correct. So the four tables are actually the what? The four conceptual data model we have. That's very correct. So what about the logical uh, data model? So what would be the logical data model? Any idea? All right, I don't think you can go ahead.
Fixing in our attributes.
The attributes. That voice sound familiar. Is that Mr. Lekon?
Yes, boss.
Aha, you are welcome. All right. So your attributes are the what? Are the logical data model. So like the order ID, the order date. So the moment you fix all of this, you have given your what? You have given your logical data model. And the physical data model is when you put the what? The data type. So basically, from what we've learned now, that means we have an entity, and the entity has attributes. What is missing, Mr. Adeniji? What is missing in this data model? We have entities already, we have attributes. What is missing? One more component is missing. Anyone? Relationship. Relation. You remember the relationship I said, not the other relationship. Oh. Now the relationship we need here is to establish a relationship between the two tables. And what you need to do, you can start with any table actually, but let's start with the fact table. In this table, so let me pick somebody. Let me pick a lucky winner. Somebody who's going to win my prize tonight. I already have 5 people that's going to win my prize. The first 5 that join this call. So let me pick one more person. Taufiko Salami. Are you there, ma? Are you there?
Good evening.
Good evening, ma. How are you doing?
Yes, good evening.
How was your day?
I'm fine.
Now from this table,
Thank you.
which of this table is the fact table? Mention the fact table and mention the dimension tables.
Oh, no, I'm sorry. I just joined the class. I don't know
Oh,
anything.
you just lose the prize. Okay, let's. Can you pick someone? Pick someone from the call. Just mention somebody's name.
I'm strong.
Armstrong.
I'm strong.
Okay, Armstrong.
Yeah.
Are you there? Are you there? I think he's not there. Can you pick someone else?
Doris.
Doris. Doris, are you there?
Yeah.
Yeah, I
Uh,
can hear my name clearly.
okay. Now you have a prize here now. So you are asked to mention the fact table and the dimension table. What is the fact table and what are the dimension tables in this table?
Um, I'm using my phone, so I'm trying to
Okay, it's to zoom in, right? So we have the orders details table, we have the orders table, we have the pizza table, and we have the pizza type table. Which of these table do you think will be the fact table, and which one will be the dimension? What do you say?
That's one.
Orders table. That is correct. Thank you very much. All right. So the orders table is what is a fact table here? Is a transaction table. It changes often. So let's start with the fact table. So if I start with this fact table, it means every other one will be what? Will be a dimension table. Sorry guys. So others will be a what? A dimension table. So now let's establish a relationship between them. So if you look at this, if I pick my orders table, there's no what? There's no guys relating to these guys. So you can pick another one, like for example, okay, very good. So if you look at this now, the others details. So the others detail has a primary key, and it has a what? A foreign key order ID. So that means that if this table has an order ID, it means you can establish a relationship to these guys. So how do you now establish a relationship on this platform? All you need to do is just drag this guy. You can see I just put my cursor on this angle. You can see the moment I click on it and I hold, I can be able to draw a line. But pay attention, I'm dragging this line from this point to this what? To this point. That means I'm going from the foreign key to my primary key. So that draws the line. Now it's asking me what type of relationship do you want to establish between the orders details and the orders. Is it one to one? Is it one to many? Or many to one? What relationship between the orders and the details of the order? Any idea? Any idea, guys?
I think it should be one to one.
One to one. Do we all agree with him?
Yeah.
Yeah, I think I agree with him too, and that's correct. Because when you pick an order, if you pick one order, the details of that order should not appear multiple times. So you can see an example of one to one that we are talking about. So I'll click on one to one, and that establishes one to one relationship. All right. Now the same thing. Let's pick. Okay, we also have another word, pizza ID here. So that means pizza ID can also what relate to this guy. So if I pick pizza ID here, so from my foreign key to the primary key. Now what type of relationship should it be? From pizza ID here to pizza ID here, what type of relationship?
One to one.
One to one. Is that correct? Any other opinion? Let, let, let me do it again. Pay attention. I'm dragging it from here, pizza ID, from the foreign key to the primary key. Or if you like, you can also drag it from primary key to foreign key. So because you have one to many, you have many to one. So if I drag it from here, from the primary key, please mute your mic. From the primary key to the foreign key. So pay attention. So how many pizza will appear on other details? How many times can it appear? So that's how you relate it. So if I'm coming from pizza to other details, if I pick one ID of pizza here, how many times can it appear in the other details?
One to one.
Yes, this will be one to many. This will be one to many. And why is it one to many? The reason why it's one to many is because when you pick one pizza, let's assume you pick one pizza, ID one. Maybe there's a pizza in the database, and that pizza is having an ID one. In the other details, that ID one can appear multiple times. Because what happened if I purchase that pizza, Doris purchased that pizza, Mr. Lekon purchased that pizza, that means that on our other details it will still be appearing as what? Pizza ID one, ID one, ID one. Because it means that one pizza here can be purchased multiple times. So if you go ahead and say 1 to 1, it means that if one person has purchased one pizza, no customer again can purchase that pizza. And is that correct? No. So here should be what? One to many. So from here to this place is what? One to many. But from here to this point, it will be what? Many to one. So it means that one pizza can be purchased multiple times. Then the last, which is the pizza types. So who can do this for me? So which table do I need to relate this guy with? Which table can I relate pizza type? So I think guys are having it pizza.
Pizza.
Using what field? Using
Pizza type I.
pizza type ID. So if I come from the primary key, if I come from the primary key, foreign key rather, to the primary key, so that will be what relationship? What relationship?
What do you mean?
No.
To one.
Mm,
What do you mean?
no.
Many to
Many to one.
1 to 1.
Many to one. You understand? Because you know that two pizza can be of the same type. Is it not possible? Just like when you pick a product in an e-commerce platform, you pick a product, a bag and a shoe. They can belong to the same category. You understand? Just like when you pick a phone and a plasma on Jumia, for example, they belong to the same category, and that category will be what? Electronic device or an electronic appliance. So that's the same thing we are doing here. So
Sorry, coach. I want to get something clearer here.
okay,
In this context of the pizza,
yes.
is it possible to have different pizza type for a particular pizza? Because if I'm
Can,
buying
can you come again?
pepperoni pizza,
Ca
for example, I want us to be hypothetical.
okay,
If I'm buying pepperoni pizza,
yes.
will it have another type of pizza? Is it not one particular type of pizza?
Okay, so the way this data is structured, so when I share the data with you, you all will see that. So the way the data is structured, that we have some certain pizza, and they have what? The types of their pizza. I don't eat pizza. I don't know different types of pizza. You understand? So when you pick a type of pizza, so under that type, there are many pizza under that type. You understand? So that it means two or more pizza can belong to the same type. So just like for example, the way you say pepperoni pizza now, pepperoni pizza can have some other maybe pepperoni pizza with let's say with burger, or pepperoni pizza with sugar, pepperoni pizza with you understand. So under that pepperoni pizza there are also some other what there can be some other categories of that type. Just like where you have shoe and bag happen to be what? Accessories. So the accessory is the type, the bag and the shoe are the products. Is that understood? All right, Mr. Adeniji, go ahead please. Please go ahead with your question. Okay, I want to believe that's a mistake. All right, Mr. Adeniji, I can see your hands are you are raising up your hands. Please go ahead with your question. Okay, all right. So I think it's 9 already. It's 9 already, and we are right on time. We are right on time. So we're able to like do this. So what we have done here is what is the data model. So any question? Any question before we wrap it up? If there is no question, kindly just drop an emoji so I know uh, my people are engaging. All right.
Please have a question.
Please go ahead, ma. Go ahead, ma. Thank you
So
very
how do
much.
I know if other details and the other how do I know if the foreign key and the primary key and the foreign key?
How do you know what? Can you come
How
again?
do I differentiate which one is the main table and I don't even know how to structure the
Okay, calm down. Can you structure it again? Just I know you are making sense out of it, but can you come again?
okay, how do I know the foreign table and the primary table and
O-
the
Okay, there
other details and the others?
okay there is nothing like foreign table or primary table. What we have is fact table, dimension table. So what you meant to say is how do you identify which one is the primary key and which one is the foreign
Yes.
key, Abi? Is very good. So it's very simple. To identify the primary key, what is the primary key? The primary key is a field on a table. Pay attention. The primary key is a field on that table that you will use to uniquely identify the information on that table. Now that means that if you look at a table must have a primary key. And most of the time, we usually put this as the first column. But mind you, you can put it as the last column. You can put it in any order, it doesn't matter. But best practice, we usually put the primary key as the first column. That's one way you can identify it. Another way you can identify is that they usually take the name of the table with ID. Because that when I created order details ID, the name of the table is what? Order details. Then I say there's a field called order details ID. So that's another way you can identify that this is a primary key. But mind you, it's not just by the name of the column, because the name of the column does not really matter. It's the data inside that matters. But in development, we usually do this. The ID is usually the primary key is usually taking the name of the table, then together with what? ID. You understand? But if somebody use another name, it might be difficult to identify. So when you are doing your data model too, these are good practice you put in place so that you don't stress other people who will join you to work on the database or who will be analyzing database. Don't give them stress. So when if you are the one designing the database, the first column should be the ID, and the primary key will take the name of the table together with ID. So just like when you go to orders too, you see order ID. When you go to pizza type, you see pizza type ID. When you go to pizza, you see pizza ID. That's for the primary key. But for the foreign key, this foreign key, they are column that are used to establish a relationship to another table. That means that that column will be in another table. Like for example, look at order details. Order details is having order ID. Already you know that this order ID is already on the orders table. So it shows that this order ID here is meant to be a what? A foreign key. Because you are on orders details table. So for me to see order ID, that means that this ID is not the primary key. It's the ID that reference the order table. So it must be a foreign key. Do you get my explanation?
Yes, sir. Yes, sir.
Alright, so that's how you identify the primary key and the foreign key. But mind you, the name does not matter. But for good practice, always put the name like this. So your primary key should take the name of the table with an ID. You understand? That way it make it easier for developers or analysts to be able to like relate with that table or database. So this is where we are going to wrap up for tonight. So we've been able to like at least understand the core.
Sorry.
Okay.